Hello, everybody. Today we're going to be going over leetcode 217 contains duplicate. And this is going to be the start of my playlist of me solving every single problem on Neetcode 150 list. So this is going to be our, I guess, start. So basically for these videos, we're going to usually go over like a brute force solution and then try to optimize it from there. So for this problem specifically, we are given an integer array nums. Return true if any value appears at least twice in the array, and return false if every element is distinct. And we're given three examples. Two cases where there is a duplicate, and one where there's not. And we're first going to be going over the, I guess, the brute force solution. For our constraints, we're not really given much. Usually sometimes we'll be told that we can't do certain things like sort an array or use certain, I guess, um, particular functions in order to solve the problems. But in this case, we have actually a lot of ways to solve this specific problem, and we'll be going over the brute force way first. In regards to just basic, I guess, array handling. So if we're given an array like this right here, 0, 1, 2, 3, and there's no distinct, I guess, unique, well, they're all unique values, I mean, and there's no duplicate value. Basically, for our brute force approach, what we're going to do is we're going to be setting up two loops or two for loops in order to just compare every single one with one another. So I guess our first loop is going to contain like this element right here. So it's going to start as 0, and we're going to have to find a way to make it so that it is going to be, say this current one is n, it has to be n plus 1 until the end of the array. So we're going to be comparing 0 to 1, and then 0 to 2, and then 0 to 3. And basically our for loop is going to be this red arrow right here. It's going to be going through each individual element of the array. And once it's finished, it goes back to, I guess, like back to the beginning. And once it's finished and we compare them, then we can move our first pointer using our first loop to our second element. And then we can compare our second element to every single, I guess, every other element in the array. So then next, since it's going to be n plus 1, and this is going to be n, it's going to be at 2. One is going to be compared to 2, and then one is going to be compared to 3. And then we're going to move our pointer here, and then we're going to compare 2 to 3 because it's going to be I plus 1. And since it's going to be, since this red loop, or I mean, since this red arrow, the for loop for this red arrow is going to be focused on going from n plus 1, which is basically wherever this is, but the element to the right of it, till the end of the loop, it's going to basically cap out right here. And we'll be able to compare, I guess, the second one, but ultimately that's going to be what we do for our brute force solution. And let's take a look at what it would look like in code. All right, so let's do this in code. So we'll say for n in nums, or n in range length of nums, that's going to be our first arrow, and our second arrow is going to be for j in, I guess, range from n plus 1 to length of nums to make sure that we don't go out of bounds. And we'll basically say if the current number at the current pointer is equal to our red arrow or whatever element the red arrow is holding. If that is it, then we return true. And basically, since we're going to be going through the entire array, um, we can return false if this if statement is not, um, I guess, uh, executed. I mean, if this statement isn't true, then basically we're just going to return false because we'll go through the entire array. So, oh, whoops, sorry. Sometimes you get confused with I and J and N. But yeah, now, but as you can see right here, where our expected has come out, true, false, true. We see right here, 1, 2, 3, 4. These are all unique values. Thus, it is false. It doesn't contain a duplicate. And 1, 2, 3, 1 does contain a duplicate. Thus it outputs true. Same logic with the third case. And this is going to be our brute force solution. And as you can see here, um, our time complexity for this, I guess, specific way of solving this problem is going to be O sub n squared. And we have to set up two for loops in order to go through this array twice, like pretty much. So it's not very efficient. Also given in Python. Python is a very efficient language where you could find a buttload of different functions to help us out with these problems. But in this case, it's just not very efficient. You have to go through two for loops, and there's definitely a better way of solving this. And let's take a look at the whiteboard to determine, or at least to help, I guess, understand what we can use instead of this like not very efficient way of solving this problem. All right, so before we had to go through this array twice in order to determine whether or not it contains a duplicate or not. But what if we created a set that basically contains all scene characters? So it would just be a new set. We'll call it scene. And basically we will contain every single I guess every single unique value or every single value that's been seen. And another thing about sets is that they contain all unique values. Thus, if we create a set, it's going to be all unique values. So we'll be able to contain 0, 1, 2, 3. And say if there was some sort of other character, like another 1 or another 0, then it wouldn't contain that. And it would just have that in the set. And what we'll do is we'll compare this set, or at least I guess every character in the set to if it is in this array right here. So basically we'll say if if um if the current number, I guess yeah, if the current number is in scene, then we basically give our true value. We return true, if this is in our scene set. So 0 will be assigned to our scene set, so will 1, so will 2, so will 3. But if there's another character, say there was a 1, right? Like I was saying before, like another 1, right? It would go back. Oh, whoops, wrong layer. It would go. It would go to the end of this loop, right? It would get to 1, and since 1 is in, I guess this scene set, then we will return true. Um, and we'll add it to the set, but it doesn't really matter. So we don't really need to worry about that. Um, but since it is seen, or at least since this number is in like this scene set, which we've defined by going through each element in the array, since it's in this set, we're going to be returning true. So that's basically the logic that's going to go behind solving this problem, but this time using, um, I guess, I don't know why. It's weird. We're going to be using hash sets. Before it was brute force, and this solution is going to be um, concerned with hash sets. So let's take a look at what that would look like in code form. All right, let's I guess, well, I guess we could do this. We'll say scene is equal to a set, right? And we'll say for n in just the same as before, in the range of length of nums, um, if n in scene, then we will return true. But we're going to be appending every single, um, I guess, element of this array. So we'll say scene.add n. And then we'll return false if, like, this if statement is not executed. Or rather, if this if statement is not true. So let's try running this. Oh. Um, see, if n in range of length and nums, if n isn't seen, return true, scene.add n. It's weird. Oh, yeah, yeah. Actually, well, we wouldn't really need to use this for n in nums because we're not really manipulating the I guess array. So we're just going to be going through just the numbers like each individual one rather than the range. There you go. So we see here we're given a duplicate or at least an integer. I mean not an integer, a array where there's a duplicate value, one where there isn't, and one where there is again, but multiple of multiple. And we're given, well, true and false, respectively. And as we can see here, we only go through the loop once. So only go through, well, only go through the loop, only go through the array once. O of n times complexity, which is pretty good, but we could optimize this further um, in order to get something that's less lines of code. But this is the standard way of solving this problem is using sets. So let's do this. Let's try comparing the lengths of the scene set with the original array. So as we've talked about before, sets have unique values, like all unique values, regardless of if you add a new um, element to the array. So what we could do, instead of creating a whole new set and adding to it and comparing, instead of doing all that, what we could do is create a, I guess, a set version of this array right here. So we could say scene equals set nums, and we can compare the length of this array compared to our new set array. And basically our set array isn't going to contain duplicate values, so we're just basically going to say return. We're going to return I guess the Boolean value, whether or not this is like true or false, of scene compared to the length of nums. Return the length of nums less than the length of sums. So basically, if this is true, if the length of scene is less than the length of nums, then it is going to be true, and it's basically going to be bigger than, well, the length of, or well, less than the length of nums. The nums is going to be bigger than the length of scene. So it would basically be, our new set would basically look like, if we're given 1, 2, 3, our new set is going to look like, well, I should have just did 1, 2, 2. Our new set is going to be looking like 1 and 2. It's going to have a less length compared to the original array. And so we could just return the length of our scene array, which is just the nums turned into a set. And if it's less than the length of nums, then it basically will return the Boolean value of whether or not this is true. And whoops, I shouldn't have ran that because I have... Oh, huh. Never mind, I guess that was okay. But as you can see here, it's a surprisingly effective way of solving this problem. It's very straightforward, and you see here, um, all of these are true and false, and this this array is true as well because it does contain a duplicate value. So this is going to be the same. So this is going to be O sub n time complexity. But it's just a more, like, I guess, time efficient way of solving this problem. Because you can literally just compare the lengths of both arrays. And yeah. And that is going to be it for today. Um, it was a bit weird navigating how to do this kind of video, and this video is kind of long for a very easy problem. But yeah, I just wanted to go over our brute force solution, our hash set solution, and our hash set length solution. So this is pretty good. This is O sub n time complexity. This is our, I guess, our basis for our like a good solution is creating a set and comparing each, I guess, the set with each, or not, like seeing if every single element is in scene, and yeah, yeah, that will be it, and also our brute force solution, and that will be it for today. Um, I'll probably try to find a more time-effective way of doing these videos because this was a bit of a long video for just these, or just explanation of these three solutions. But yeah, we're gonna be doing or attempting to do Neetcode 150, and we're gonna be going by every single problem. And yeah, see you for the next video.